Okay, great. Well, thanks for having me here. It's really exciting to be here, just because it's the first time presenting a lot of my work to an audience of people who are so far outside of my discipline. Just to make sure, how many artists are in the room? Yeah, a couple. All right, designers? You can use both hands, one for art, one for design. So I'm Aaron, as mentioned before. I'm a media artist and interaction designer. But most people know me as datadreamer. It's because for the last decade or so, I've been doing a lot of creative work using data and working with systems that I think are interesting that I derive data from. And I have three thoughts for today. One is about abstraction as representation. A lot of people think about how they want to visualize their data, and they come to conclusions that they can use very simple things. You can use a bar chart, you can use a line plot. These are great for very simple methods of visualizing basic data sets, but sometimes you have to go outside of that if you're going to represent something that is kind of outside of the norm. Another is visualization as interface. So it's also very typical for people to collect a data set, create a visualization from it, and then you have this kind of static product that represents all of the qualities of that data. What I'm more interested in is creating these kind of information design systems that you would pipe data in, be able to use it to look at and understand, and then kind of explore that data through the visualization. And the third is change perspective often. I really want to emphasize, don't get locked into a particular representation. Play around with how you want to view your data, and specifically that goes back to what everybody up here has said is back to the source, the question that you want to pose against that data. I did my undergraduate at San Jose State University, where I got my BFA, Bachelor of Fine Arts, and then at University of California, Los Angeles, where I did my MFA. These are both very liberal arts programs, so I did my fair share of mixing paint and drawing naked people, but when I wasn't doing that, I was studying different programming languages. I was looking into what kind of contemporary design practices were going on. But everybody right now is going, what am I doing here? What does art have to do with data? A lot of things. So we'll start off with art is about the human condition. This is kind of the be-all, catch-all description of art that is, I think, referenced quite a lot. Anything that is considered art reflects somehow the human condition. It's a byproduct of the human condition. Visual art is communication through form. So if we want to communicate something about the human condition visually, we have to do it through form. Representational art is visual art focused on a subject. So if we really want to focus in on that subject and we want to communicate it through form, we have to represent it somehow. I chose this image because what I'd like to do is give you a brief 5-minute introduction to art history and modernism. Anybody take an art history course before? All right, that's better than I expected. Great. So you're all familiar with this image, I'm sure. This is Washington crossing the Delaware. This was done in 1851. Beautiful imagery. Just really captures the scene. There's so much realism in it. You can see the expressions on people's faces. You can see the wrinkles and fabric. There's just an amazing amount of detail, and this was so popular at the time. Now, if we fast forward about 25 years, this is how painters started painting in Paris at the time. This is by Renoir. This is one of my favorite examples of Impressionism. And what we see here is kind of a departure from realism, because realism was inequipped to actually convey what Renoir wanted to show with this scene. What you see in the previous image that you don't see here is details in fabric, details in facial expressions. What you see here that you didn't see in the other one is a lot looser lines. You see kind of a blurring of forms as if to indicate kind of an action. So there's what he's attempting to convey here is the impression of the scene. You see a lot of the shadows from the trees. You kind of get the idea of what it was like to be the artist there kind of experiencing the scene. Of course, throughout modernism, this kind of evolved. The abstraction continued based upon what it was that the artist wanted to communicate. So after Impressionism, we had Expressionism, where the artist was really trying to instill emotion into a painting that would then, evoke the emotion in the viewer. Fauvism was really focused not necessarily on the subject, but on how the color of the light bounced off the subject. Cubism, collapsing. We lost a lot of detail in terms of what you can tell from the person's facial expression, but we're collapsing gesture over time into a single image. So what you see with all of these different ideas is that you're kind of reducing fidelity of one component in order to communicate and kind of raise the emphasis of another one. Now, all of these were representational until we get to these last two here, suprematism and neoplasticism. Now, these were out of Russia and the Netherlands, respectively, in the 1910s and 1920s. And this were artists that were like, well, what's better than rectangles? Rectangles are beautiful. I love triangles and circles. What's more perfect than geometry? Which is actually, it's a great thought, because what they were doing is they were really predecessors of thinking about how the visual cortex works and how we, like human psychology works in viewing different things. So that led way to this guy, Vasily Kandinsky, who many of you, I'm sure, or at least the art historians are sure to be aware of. He is the kind of grandfather of abstract expressionism. So what the idea was is taking the concept of expressionism, where you want to evoke emotion, and then do it through abstract form. And being that he was so inspired by the geometric qualities of the supremacists and the neoplasticists, in order to create a visual language to convey the subjects that he was trying to evoke. And at the time, the subjects were basically emotion. Now, he went further and wrote about this in his book, Point and Line to Plane, which was published in 1926. And this is where he really outlined all of the different qualities of form. So from the point, from the one-dimensional dot to a two-dimensional line, to the plane, and so on, to color and shape and orientation, and really focused on just composition as a whole in terms of how that influenced visual perception. Now, in the book, this is a great example of very early kind of visual language. So he took Beethoven's Fifth Symphony, where you can see the notation at the top, and created a new visual notation at the bottom. Everybody's familiar with this? Everybody, you want to do it with me? Dun, 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 dun. Okay, you don't have to. So the idea here is that it still communicates these things, but he has really reduced the visual form down quite a lot. Now, a couple years later, while Kandinsky was teaching at the Bauhaus, one of his students, Heinrich Sigrid Bormann, did this project, which is actually, it's a homework assignment from a university student from 1930, analysis of a piece. And so he took the inspiration from Point and Line to Plane, where he took notation of a contemporary musical score, translated it into the point notation, which you see at the very top, which is what Kandinsky came up with. And then he came up with these other types of visual languages in order to kind of convey the different components of this music. So I find this very, very interesting, because this is an 84-year-old example of data visualization, all completely done by hand. This would actually lead to very important developments later on, which Jacques Bertin published in Sémiologie graphique in 1967, which was really about understanding quantitative information by dovetailing a lot of that activity to the visual cortex. So here we have two maps, and they represent the exact same data. The map on the left, which is a bit difficult to read, is a bunch of different sectors of the country with some kind of quantitative value. It's a number between 18, -8, -15. They're kind of all over the place. Now, the map on the right is the same values, but they have been transposed into dark and light shades. So if you were to read the map on the left and try to analyze where the high activity and low activity was occurring in the country, you'd spend an afternoon trying to figure this out, and you'd probably transpose it into a spreadsheet and start sorting by columns. If you look on the right, you understand immediately. These are the highs, these are the lows, this is the distribution, that's it. So at the same time that Kandinsky and his students were doing some really interesting work with abstraction, there was another pivotal event in abstraction in cartography. This is the London Underground Tube map from 1932. And what you see here is a map that chose to retain fidelity of geolocation. So the location of all of the stations and their tube lines here is representative of the reality of their location in the city. Now, at the time, a technical draftsman for the London Underground named Harry Beck, said, this isn't the most clear map. It's a little difficult to read, and I kind of want to take a crack at it. So in his spare time, he came up with this. So what you see here is an abstraction where now we've removed the fidelity of geolocation, and we're more concerned about the system as a whole and its components and how they connect to each other. He was very inspired with electrical schematics because that's what he worked with on a day-to-day basis. And if anybody here has seen electrical schematics, you know that they don't look anything like the output. It's this complete abstraction that's just focused on how the components fit together in the system. And of course, you see this in pretty much every major metropolitan city. This has been duplicated thousands of times across the world. So back to my work. My inspiration comes from interactive art and data visualization, public space, and they tend to overlap in a lot of the work that I do. And throughout the different classes I've taken and different kind of creative modes that I've gone through, I've created different work that has been very ambient to very analytical, some very politically motivated even. After I got my MFA, the next day I started a fellowship at the NASA Jet Propulsion Laboratory. I was not working with this toy, but with this one. This is the Mars Reconnaissance Orbiter. It's been orbiting Mars for a little over 8 years now. It does a complete polar orbit of the planet in an hour and 53 minutes. And the particular piece of technology I was working with is this little thing right down here, which is the Mars Climate Sounder. And what the Mars Climate Sounder does is it takes limb observations of the atmosphere. So as the satellite's constantly going around the planet, it's looking up and down the atmosphere and taking measurements of all sorts of things, from light extinction to trying to look for water vapor, all of these different characteristics. So what I did when I arrived is I looked for the raw data. I went to the satellite data source, and there's actually an open archive. You can go online and download this stuff. It's totally publicly available. And I just started plotting it. So the first step being, let's see if my expectations are right. Let's just see if this thing plots and it looks like it's orbiting the planet. Yes, it does. Okay. The next thing was looking at some of the unexpected results. So we see, because part of the mission for the Mars Climate Sounder was studying the polar ice caps. They wanted to see how water ice moved over the seasons. So you see these kind of straight lines until it gets to the poles, at which point it kind of does this kind of shotgun scatter scan because it wants to get as much information as possible about the poles. And then you also see kind of like here where you see this artifact as if it kind of got off course. And that's because the whole satellite rotated for a second so that the high-rise camera could take a really nice photo of a geographic feature. So there's these kind of things you have to look for in the data that you'll discover are maybe artifacts of something else. Now, I was also working with a climate scientist from Caltech, and he was averaging a lot of this raw data together in order to get these kind of seasonal overviews. And what we're looking at here is the surface, just flattened out equirectangular surface of Mars. The values are essentially climate values, and then the height that you see here is the standard deviation. So as I was talking to the climate scientists, they go, okay, well, we've been looking at the climate values, but we haven't been looking at the standard deviation. And what's interesting about that is that essentially reflects the weather, how much change in weather is happening. So you see here, this is one of the main volcanoes on Mars. Olympus Mons is right next to it. You see a lot more standard deviation in the poles. So there was a lot of interesting kind of discoveries that we were able to see out of this, just playing around with the kind of visualization. A few years after I did my work at JPL, I went to MIT, where I had a research engineer position at the Sensible City Lab. We were working on a project at the time called Live Singapore, which was a 5-year initiative and had only been about 6 months into it at the time. And I was brought in to work on visualizations of all of the data that they were already analyzing in order to put together an exhibition at the Singapore Art Museum. Now, the first data set that I got were taxi data. Any given time, there's between 6,000 and 12,000 taxis moving around the country of Singapore. And I was able to get their location data, which looks like this. We basically have a timestamp here. We have an anonymized driver ID and vehicle ID. We have longitude, latitude, speed, and then a status. So whether the taxi is available, POB, meaning passenger on board, whether it's on call, so it's going to pick somebody up. So we can kind of evaluate status. So the first thing I do is just plot it out. I want to see what it looks like. I want to see if it actually matches up with my expectations. The same thing I did with the satellite data. Here we can see, it's overlaid on top of a map. You can't see anything, unfortunately, but I'll describe it to you. So right now it's 6 o'clock, and there's a bunch of activity moving all the way to the right there. And what you see there, that's Changi Airport, which is one of the busiest airports in the world. You see a lot of vehicles moving into that, and then later in the day, you begin to see them start coming from there and moving to the downtown area. But again, it's very similar to the satellite data. You also see a lot of artifacts. So there's, every once in a while you see a little yellow thing zipping across, and that's because there's like a bad location point. And so you kind of have to see these things and figure out how you might, filter out the noise from the good data. We were also looking at, unfortunately you can't see this, looking at speed, so green being fast, red being slow, status of the taxis, so these yellow being there's a passenger on board, and so you can see that the highways are being outlined because there's actual passengers in these cabs, and then the blue being the free taxis on the surface streets, or just seeing when passengers get picked up. And we were also getting radar information about precipitation. So we were getting all of this weather data, and what we wanted to do is we wanted to look at how the weather was actually affecting the taxi drivers, because what a lot of the researchers who were stationed there were noticing is that, and I don't know if any of you have been to Singapore, but it's constantly 90 degrees, 90% humidity, and either super sunny and beautiful and blue skies, or just torrential rain and just awful. So when it rains, it pours, and when that happens, the drivers of the cabs will often just kind of pull over and stop somewhere and not pick anybody up because they're completely liable for any damage that occurs to the car. They get pulled off the road, they have to pay for all of the repairs, so they just don't want to deal with it and they just park somewhere. Obviously, there's a big issue because everybody who's stuck out in the rain wants to get a cab, but they can't get any. So this was kind of the big component of what we were looking at here. Another data set that we were looking at was Singtel. You guys want to talk about CDR some more? So Singtel is kind of like the AT&T of Singapore. They're just this massive phone company. And we were looking at these data sets that we're talking about, hundreds of millions of records a day. And we had to really simplify it in order to get a holistic view of the country's activity. And so we broke it up into a grid, and I started playing with different representations, whether they were kind of like this 3D bar chart or a mesh kind of reflecting topography, or Sensible's favorite, which is these kind of floating squares. And we saw some things that we would expect. So one being a lot of activity happening in the business district during the day. As it gets later, so it's almost approaching midnight. Now there's a lot of activity in Clarke Quay, which is this amazing nightclub, district. We would also see there was an increased activity in Galang, which is the red light district. And then one thing that we actually discovered, which was completely outside of our expectations, is we were looking at a couple weeks of activity, and then we were seeing about an hour or two every Sunday afternoon, this massive spike just occurring out of nowhere in the Little India neighborhood. And I thought, this can't be right, because it was a bigger spike than we would actually see in the business district at any time of day. I said, this has to be an error. Let's look at the code. Let's look at the data. Let's figure this out. Well, one of the researchers who was working in the lab was Indian and knew the community very well. And he told me that what would happen on Sundays is that there's a park in the area, and the whole community would just gather in the park, and everybody would make their calls home. So everybody was calling back to India at the same time. Everybody's having these big kind of conference calls with their families back home. So the last thing I want to show you, and I'm going to try to go through this really quick, and I've actually never shown this to a public audience before because I consider it an unfinished project. In 2012, after the election, I don't know how many of you are familiar with the White House Petition website. The White House operates this site where anybody can go on, put together a petition, and then try to collect signatures. And if they reach X amount of signatures within the 30-day threshold, the executive branch may acknowledge the subject. Well, after the election, there was a petition from every single state to secede from the Union. Now, the one that actually got the most attention was from Texas, naturally. Now, Texas, within 4 days, managed to gather over 100,000 signatures for its petition to secede. And this was very interesting at the time because at the time you only needed 25,000 signatures, and I think now it's 150,000 or something. And what you could do is you can get very interesting data. We were able to get a first name and last initial. Now you can only get initials for privacy. We were able to see the city and the state that they were from. We could see the day, not the time, just the day that they signed, and then their signature number. And I'm on Reddit. I don't know if there's any Redditors in the room. Hey, you guys admit it. All right. So I subscribe to a lot of these kind of data enthusiast subreddits, one being data sets. And the first thing that came up was this guy saying, oh, hey, there's this petition. I'm really interested in the location data because I want to see, how much activity is in Texas, but I want to see how many of the cities around the country just want to see Texas secede. So overnight, it was like a race to collect the data. And so me and another person who I met up with online, we started parsing all this data, scraping it as fast as possible, and then playing around with it. So I was able to get the data and then start plotting it in a very basic way. And you can kind of see, it's not so clear, maybe you can see it a little better on this monitor, but there's a lot of activity happening in Texas, but there's all over the country these little blue dots that specify that kind of as if the population distribution, there's an equal amount of people that say, all right, Texas. What was really interesting is you could actually see this in Puerto Rico, Hawaii, Alaska, so there was kind of it's an even distribution all over the place. Since we were actually getting first names, the person that I was working with, he was like, well, let's try to do some kind of a gender estimate based on names. So we were working with this data set to kind of come up with an approximation of what the kind of gender balance of particular subjects would be. So at the time that I was experimenting with this, it was early 2013, this was the most male-dominated petition, which was not allow the FDA to regulate premium cigars. The most female-dominated one at the time was finalize standards for gluten-free labeling. So I went ahead and I created this whole kind of sketch. This is a very interactive visualization where you can kind of go in, zoom in on the different data. We're looking at the premium cigars petition. We see that Miami is kind of the top right here. There's a lot of activity. You can see the bar keeps growing. Down here, we can select Florida and get better information about the kind of signature distribution. So we can see, 6% of all of the signatures in total came from Florida. We can, go and highlight another state. I think I go and highlight Texas here. Now you can see the political distribution. It's much more Republican-leaning in Texas than it was in Florida. So you end up seeing these kind of interesting trends here. What I also did here, which you'll see soon, is I paired the city information. I took the city and state information, looked up the county that it's in, so that I could get the presidential election results from that county. What I could do with that is figure out the kind of Republican-Democrat balance for each city. It's not super exact, but it's an approximation. And then what we could do there is kind of essentially look at the political distribution here geographically for each of these different subjects. So the next steps that I'd like to see with this particular project in order to wrap it up completely is a web service for scraping the petitions, which I've already pretty much created. Porting the visualization to WebGL, so allowing all people to access the visualization and use it as an interface to the data. And then once that becomes public, use that as a catalyst for a petition on the White House website for an API, so that no one would have to scrape the data anymore, just an open API that they say, okay, work with this, do your research, figure out more about the political balance of these different subjects. I think that would be really amazing. So on that note, thank you.
Thank you very much, Aaron. From Renoir to Mars to cigars and Singapore, it's truly remarkable.